It's me again. In the previous videos in this series, we have seen that electricity is energy that can be measured using instruments. We now understand that Gibbs free energy is a scientific theory that proves that free energy immediately fills any void. There is no such thing as zero energy. I showed this by showing that the water in this glass immediately goes to this level and there is no hole in the water. This is a similar thing to Gibbs free energy. Energy takes up all the space. In this case it's gravity acting on the surface of the water and filling the glass. Confusion arises from the fact that for every force there is an equal and opposite force, but this does not mean there is a negative force. It means there is another force going in the opposite direction. Newton's cradle shows this very well. This ball is driven by the force of gravity and it transfers this energy into this ball, which goes up and then comes back down because the gravity is forcing it back down in the equal and opposite direction. So this explains that there is no zero. It is an equal and opposite force. There is no such thing as zero energy, but there is a zero on all meters because we are making comparative measurements, and zero will appear on the display if there is an exact equality between the two inputs of the meter. We can test this by simply joining the leads together as a continued metallic, like I've done in this, whoops, upside down. Continuous metallic connection between the two inputs. When I switch it on, zero shows on the meter because there is no energy between the two ports. So there is no potential difference. The copper wire has no energy. It is equal. The amount of energy going into each of these ports is equal. If we put a dry cell battery between the two ports, like this, a dry cell battery, the active and the common ports, and we switch it on, we can see that there is 1.11 volts, which is a potential difference between the two ends of the battery, and this is caused by the corrosion reaction within the battery, and it creates an electromotive force of that value, 1.11 in this case, because the corrosion reaction between the shell of the battery and the acid within the battery. Early corrosion engineers put a piece of copper in a saturated solution of copper-sulphate. copper sulphate. Okay. They called this a half cell. They put this on the ground in order to get a voltage measurement that they called the pipe to soil potential. They called the copper in the saturated solution a half cell. And later on I will explain that it is not a half cell. It is an electrode. They said that a reading of negative 0.850 volts indicated that the pipeline would not corrode. However, pipelines continued to leak when the value of negative 0.850 volts was obtained. Some people tried applying a shift of 300 millivolts from what they described as the natural potential, but still pipelines leaked when they met this criterion. Others said that a shift of 100 millivolts would do the trick. If this was taken immediately, the cathodic protection system had been switched off. I recognise the basic error is in the measuring procedure itself. I was told that copper in a saturated solution of copper sulphate had a known potential. This is not true. It varies with temperature. Copper sulphate is produced by dissolving copper metal in a hot concentrated sulfuric acid. Copper wire has to be pure because this determines the conductivity, so we can strip some wire for our experiments. We can also buy copper rods to the required specifications. We can put the copper sulphate solution in any non-conductive container, and we can use the material that is absorbent, piece of wood. Okay, that will do the trick. And use any material that is absorbent to make an electrolytic conductor to the ground, because the electrolyte soaks into the wood, and with this we contact the ground. In these first experiments we do not need to make contact with the ground to make our observations, so I've made an arrangement of a piece of copper and a piece of wood with which we can make contact at the top of the plastic tube. When I switch this on to volts, you will see that there is in fact a potential difference between the wood, the saturated wood, and the copper itself. You can see that this is not stable. It reduces with time. And I will go into this further with the next experiment, which will prove that this arrangement is not a half cell and it is not a stable potential.